What we'll be working on today is dividing a polynomial by a monomial. So this is how you would see it. And you might say, what's the strategy? Well, the strategy is to put your common denominator under each term. So now, in a sense, you have three examples. You set them up as three individual terms, and now you just simplify based on the things we've talked about. So here, this answer will be a negative. And since the numerator and denominator are the same, it's just a -1. Now here, because it's a negative divided by a negative, the sign will be positive. And you could simplify a little bit. 4 will go into 8 twice. 4 will go into 12 3 times. And when we take the exponent from the top and subtract it from the 4, we're left with an x on the bottom. Now, for some of you this might be unusual, but that's perfectly correct. Now for this last one, notice nothing cancels out. So we need to note the sign. So we have a positive and a negative, so this will end up being a negative. 11 over 12x to the 4th. Now an interesting thing about this example is that, in fact, this original example is not a polynomial by definition. And you might say, why? Well, because it has a variable in the denominator. This is one of the qualifications of a polynomial. You cannot have a variable in the denominator and have it called, that expression, a polynomial. Now it is an algebraic expression, it's just not a polynomial. Now in this example, what we're going to be doing is dividing a polynomial, and there is a technique that must be followed, and I will illustrate that here. So the first thing we have to decide is, how many times does this term go into our first term here? And a technique to figure that out, if you're not sure, is to take this term and divide it by this term. Now, 4 will go into 12 3 times, and a will go into there a to the 2nd. So you now have your first term there. Now the rule is you multiply this first term here by this, and you're going to get 12 a to the 3rd. And that's what you want to do. Now, you're going to take this 3 and multiply it by this, and you now get a positive 9 a to the 2nd. 3 times this, a positive 9 a to the 2nd. Now you might say, well, what do I do next? Well, you're going to draw a line, and you're going to do what to these? Well, you're going to subtract. Now in algebra, to subtract, we say change the signs and then add. So here, these cancel out, and this leaves me with a negative 12a squared. And the rule is we bring down our next term. And once again, if we want to say how many times does this go into this, we just set it up over here. So we're going to take this and divide it by 4a. Now our sign will be negative, and 4 goes into 12 3 times, and we have an a. So now that we multiply this times this, we get exactly this, 12a squared. Now we have to multiply our positive 3 times a negative 3a, and we get a negative 9a. Now, what do we do? Well, we're going to put a line, and we have to subtract this. And how do we indicate subtraction? By changing the signs. Now, these will cancel out, and this leaves me with a positive 4a here. And we bring down the 16. Now, 4a divided by 4a is just a 1. So now we multiply. 4a times 1 is 4a. 3 times 1 is 3. Now again, we're going to draw a line. And the pattern should be when you put that line, you change these signs. So these will cancel out, and this leaves me with a 13. So our final answer then would be this plus 13 over what we have out here, 4a plus 3. And that would be the way you put it into MATLAB. So in doing these, and again you need to practice, a couple of things we should note is that if there were a power missing, we would have to put a placeholder there. In fact, let's do one like that so you see what it's like. This would be a typical example of where we have a trinomial divided by a binomial. Another way this might appear is that this binomial is under a common division bar, and you would do this by long division. But as we look at this trinomial, we see it has to the third power, second power. There is no to the first power term, so that when we set up our example, we must include a value that holds that space, a space holder. So let's set it up. So y minus 2 there. And here we're going to get y to the third plus 2y to the second. Now there is no y to the first, so we're going to put in a space holder. It has no value. It's 0, that, so, but it just occupies that space. And then plus 7. So now we're set up to do it. So in a sense, we're just going to take this term, divide it by this, and we get y to the second up there. Now, y times y to the second is y to the third. A negative 2 times this is a negative 2y to the second. Now the rule is, as we put our line underneath it, we need to change our signs. So this cancels out. This now becomes 4y to the second. We bring down this term, and y goes into there how many times? Well, plus 4y. We're just dividing this by y, and we end up with 4y. So now when we multiply y times 4y, we get 4y squared. We now go a negative 2 times this, and we get a negative 8y. Now what do? When we draw our line, we change our signs. So this now becomes 8y. Bring down our 7. And y goes into there 8 times. Y times 8 is 8y. A negative 2 times 8 is a negative 16. Again, we draw our line and change signs. This cancels out, and this becomes a 23. That will be our remainder. So up over here, plus 23 over y minus 2. Now all of these examples were from the study plan, and this is the work you would use to support it. Now I've noticed in the past a number of students on their Chapter 5 test and on their final, there's often a long division problem and they don't get it correct because they haven't practiced enough. It's toward the end. We want to be sure you know this process. It involves lots of algebra and arithmetic, and following the rules. All right, well, good luck.